Hello and welcome, everybody. Yes, I'm in a penguin suit. It's favorite animal day today, so you're getting me teaching in a penguin suit, and you can just deal with it. Good morning, it's Mr. Taco. Happy Friday. Don't forget to subscribe to my channel, like the videos if you can, turn notifications on. I've heard a rumor that my students can't turn the notifications on, which is a big time bummer, because I would love for them to know when all of these lessons are coming up. YouTube, fix it. Anyway, good morning. Welcome to math class. Here's what you need today. It's the usual, something to write on, something to write with. We're working on simplifying fractions today. It's kind of the opposite of making equivalent fractions with multiplication. We're going to be making equivalent fractions with division and actually making the denominator smaller, making the size of the piece larger. So here's our I cans. I can identify a fraction that can be simplified, and I can accurately divide a fraction by an equivalent of 1. Just to remind ourselves here, the equivalent of 1 with our fractions, if the numerator and the denominator are the same number, that fraction is an equivalent of 1. 2 halves, 3/3, 4/4, 12/12, a million, a millionths, etc. Okay? If our quantity of 1 is divided into equal pieces and we have all those pieces, then we've got an equivalent of 1. And just like with multiplication, when you have a division problem where you're dividing by 1, it doesn't change the value when you get to your quotients. Okay, 6 divided by 1 is going to be 6. You're taking 6 things, you're putting them into one group. How many are in each group? Well, there's 6, because that's the one group, right? Or if you want to think about it the other way, you have 6 things, you're making groups of 1. How many groups of 1 have you made? You've made 6 groups of 1 with your 6 things. This holds true for any value. A million divided by 1, that's going to be a million. 14 divided by 1, that's going to be 14. 1/3 divided by 1 is going to stay 1/3. But with our equivalence of 1, we can grow or we can change the value or the number of our denominator without changing the value or the size of our fraction. Okay? So I could substitute 2 halves here, for instance. Does not change the value because 2 halves is an equivalent of 1. It's the same thing as dividing by 1. Same thing with if I wanted to make it 3/3. Still an equivalent of 1. Now, how does this factor in when we think about simplifying fractions? If we have a fraction that is, it's got a bit of a denominator, okay? What we want to be able to do, where did my eraser go? There it is. What we want to be able to do is get that denominator to sort of the largest possible piece, so the smallest possible number. See, if you have something like 2/6, for instance, let's draw that out. There's our 6 pieces. I'm going to shade in 2 of them, so we know we're dealing with 2/6 here. Okay? Now, what we want to do with this fraction is it's not as simple as it could be, because there is a way for us to take this fraction and make our denominator even smaller, keep our equal pieces while still keeping this same size. Okay? Because this 2/6 is actually equivalent to, and I can draw it here so you can see it, 1/3. Okay? Essentially what we did is, instead of cutting each third in half, we took each 6th and we squished them together because we've got 2/6, so we can combine those 2 pieces into one larger piece, okay, and making 1/3. So 2/6 equals 1/3. All right, and what we're doing when we do that, what we want to think about is we're actually dividing. It seems a little counterintuitive because we're sort of making bigger pieces, but we're actually dividing to sort of make our numbers smaller. What it looks like is we're actually dividing, in this case, by 2 halves. And remember, that's our equivalent of 1. A trick I was working on with some students yesterday was you can actually, to remind yourself that it's an equivalent of 1, numerator and denominator match. What I actually like to do is I'm going to draw myself a big 1 around the outside. I can even do kind of one of these too if you wanted to be fancier with your your block numbers there. That reminds me that 2 halves is the same thing as 1. It's equivalent. So when whatever my quotient's going to be here is going to have the same size or the same value as my dividend. Okay? And 2 divided by 2 equals 1. 6 divided by 2 equals 3. When you have an equivalent of 1, the numerator and the denominator are the same. You can divide straight across. Divide the numerators, divide the denominators. When we get to, a little bit later in the year, when we get to dividing by fractions that aren't an equivalent of 1, it gets a little trickier. But for now, and just for our equivalence of 1, we can really think about it the same way we do with multiplication, okay? Because the numbers are the same top and bottom. Numbers are same numerator and denominator. So 2 divided by 2 equals 1. 6 divided by 2 equals 3. So we know that 2/6 is the same or has an equivalent value as 1/3. Now, how do you know that a fraction can be simplified? If I give you a larger fraction to practice, let's say, I give you something like 18/27. How do I know if this can be simplified? What we're going to be looking for here is a common multiple. When I say multiple, I mean something that can, when you multiply it, can equal 18 equally, and something that can equal 27 equally. I've got my multiplication table over here because it is quite useful in this case. I'm going to pull my multiplication table off and bring it up close. So here with this one, ta-da, I've got, rather than the big sort of grid, I've got it sorted and arranged by your multiples of 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And what we're going to look for, is there a column that has as a product both 18 and 27? Is there a column that has both 18 and 27 as a multiple? Okay. I see it in the 3s. You see that? 6 times 3 equals 18. 9 times 3 equals 27. So we could use 3. We could divide by 3/3 and simplify our fraction. But we want to see if we can get the greatest common multiple, the largest multiple, so we can do it in fewer steps. If you use a multiple that's not the greatest common multiple, it's not the largest value, you'll still simplify your fraction, but you might need to simplify it again in order to really get it fully simplified. And I'm taking a look here, and take a look at the 9s. Oh, sorry, I am reversed from what I'm looking at on the screen, so I'm going to move in the wrong direction sometimes. Look at our 9s here. 2 times 9 equals 18. 3 times 9 equals 27. So what we're going to do, we're going to use that 9, and we're going to use our equivalent of 1 with our 9. So we're going to divide by 9/9. Okay? And when we divide by 9/9, remember, this is That's dividing by 1, so we're not changing our value in any way. It's still going to be some version of 18/27. Now let's take a look at our multiplication table again. 18 divided by 9 equals 2. 27 divided by 9 equals 3. So we know that this simplifies to 2/3. And we know that 2/3 is as simple as it can get because 2 and 3 are both prime numbers. Do we remember what prime numbers means? Prime numbers are numbers whose only multiple are 1 and themselves. So the only way with whole numbers, the only way to get to 2 with multiplication is doing 1 by 2, 1 times 2, or 2 times 1. The only way to get 3 is 3 times 1 and 1 times 3. Okay. Other prime numbers include 5, 7, 11, 13. If you ever see those in your fractions, you'll know that that's as simple as it can get because those are prime numbers. Okay. Additionally, you might have two composite numbers but they don't share any common multiples, and so that would be simple as well. All right. Let's try one more. Let's try one more here. And I'm going to hold up the times table for you, so see if we can find it. Let's go with 16/36. 16/36. Here's a fun fact. 1636, that was the house number of the house that I grew up in when I was a wee youngin'. When I was in 5th grade, I was living at 1636. And then I moved in 8th grade. That's a story for another time. Okay, take a look at our multiplication chart here. Do you see 16 and 36 in the same multiple category anywhere? Is there a number you can think of that will go evenly into 16 and evenly into 36? I don't see any of the big ones, so let's go to our small ones, our 1s through 5s. Take a look at, and I see right in here in the 4s. Do you see how 4 times 4 is 16? And 4 times 9 is 36. Okay, so 4 is a common multiple for both of those numbers, 16 and 36. So what we're going to do, we're going to use that 4 and divide by 4/4. Okay, again, we're dividing by 1, so we're not changing the value. The fraction is still the same fraction. Okay, if we were dealing with a piece of pizza, right? We cut a piece of pizza into, or we cut a pizza into 36 slices, and we took out 16 of them to look at. We want to know, can we make bigger slices and they still would be even sizes? Okay, what we're going to do, divide 16 divided by 4, or 4 times what is 16? I'm starting to see it pop up in the chat, which means we're on the right track here. 16 divided by 4 is 4. I'm going to make the dots on the divide sign bigger because I can tell from here it kind of looks like a subtraction sign. Okay? And then 36 divided by 4, or 4 times what is 36? Feel free to go back to your times table chart here. 4 times what is 36? There it is, right there. 4 times 9 is 36, or 36 divided by 4 equals 9. Okay, so that has simplified to 4/9. Okay, again, if we were to draw out 4/9, there's our 9ths. I'm going to shade in 4 of them. Okay, there's our 4/9. If we work backwards, I were to cut each of these ninths into 4 equal pieces, we'd end up with 36 pieces total, because 9 times 4 is 36. And we'd end up with 16 pieces shaded in. 4 times 4 is 16. Okay? And can this be simplified further? 4 is not prime, because 2 times 2 is 4. 9 is not prime, because 3 times 3 is 9. But 2 doesn't go into 9 evenly, and 3 doesn't go into 4 evenly. So they don't share a common multiple except for 1, which dividing by 1 whole doesn't really change the fraction, doesn't make it any simpler. 4/9 divided by 1 whole is still 4/9. So this would be as simple as you can get. Okay? Before we move on, I do want to show you, you can simplify by using less than the greatest common multiple. You just have to do it in a couple of steps. Okay? So if we were to do, let's say 16/36, and here's an easy trick. Both of those numbers, are they even or odd? They're both even, which means we can divide them both by 2. So if we divide by 2/2, 16 divided by 2, or 2 times what is 16? Exactly, 2 times 8 is 16. And then 36 divided by 2 is 18, or 2 times 18. So we get down to 8/18. But we go, oh wait, 8 and 18 are both still even, which means we can divide by 2 again. Divide by 2/2 again. 8 divided by 2, 4. 18 divided by 2, 9. And we're right back to our 4/9. Okay? And really all we did is we broke up dividing it into fourths, and we just divide it in half twice, right? Because if you divide something in half once, and then you divide it in half again, you've made fourths, right? So it is possible to do it in multiple steps. It just takes a little bit longer, which is why we want to shoot for, if we can, thinking about a greatest common multiple, thinking about what's the biggest number possible that can go evenly into both my numerator and my denominator. Okay, let's move to the digital whiteboard, and we're going to try a couple of practice ones. We're going to start here with 24/30. If you have a multiplication table at home, now is a great time to use it. And in fact, I should have put it in the materials section, shouldn't I have? Bad teacher, bad teacher, bad teacher. So 24/30, let's think about this. Does 2 go in evenly? They're both even, so 2 would work. We could do divided by 2/2 and simplify it that way. But is there something greater? Would 3 work? 24, well, 3 times 8 is 24. And 3 times what is 30? 10. So 3 would work. So we could do it by 2 or by 3. Is there anything larger? Is there anything greater? Well, if you can't think of anything right away, and you know you can simplify it one way, go for it. So let's divide this by 3/3, because we know that's going to work. Okay, 24 divided by 3 equals 8. And 30 divided by 3 equals 10. So then we simplified to 8/10. But wait a minute. Both of those are even, aren't they? So we can divide again. We can simplify again using our 2's, or 2/2. 8 divided by 2 equals 4. 10 divided by 2 equals 5. And I know 5, since 5 is a prime number, I know that this is as simple as I can get. And I saw Lily in the comments going, well, couldn't you just do it by 6 using 6/6 directly? I bet you can. 24/30 divided by 6/6. 24 divided by 6, or 6 times what is 24? Use your fingers if you need to. 6, 12. 12 plus 6 is 18. 18 plus 6 is 24. There it is. So 24 divided by 6 equals 4. And then 30 divided by 6, 5, 10, 15, 20, 25, 30. Wait, I did that by 5. 6, 12, 18, 24, 30. So we have 5. So we get to 4/5 two different ways. So we know that 24/30 simplifies to 4/5. Okay. Thank you. Let's try this one. 15/36. Let's think about what multiples, what numbers can go evenly into both 15 and 36. Well, 2 can't, because 15 is an odd number. What about 3? Is 15 a multiple, or is 3 a multiple of 15, or a factor of 15? 3 times 5 is 15. So that would work, wouldn't it? What about 36? 3 times what is 36? Well, 3 times 10 is 30. So let's start there. 10. 3 times 11 would be 33 then. So 3 times 12 is 36. There we go. So let's try that. 15/36, and we're going to divide it by 3/3. Again, that's our equivalent of 1. So we're not changing the value. If we divide by something other than an equivalent of 1, we change the value of our fraction. It's like 6 divided by 2 equals 3, right? We're changing the value of where we started, okay? In this case, with an equivalent of 1, we don't change the value of where we started, okay? 15 divided by 3, or 3 times what is 15? That would be 5. And then, I see it in the chat, 36 divided by 3, or 3 times what is 36? That would be 12. Nice work. And because 5 is a prime number, we know that that is as simple as it can get. Okay? Let's go to our last one before we get to the exit ticket. 14/41. What number can go evenly into 14 and to 41? Well, I know, let's take a look at 14, because I know 1 times 14 is 14, but that doesn't help us. 2 times 7 is 14. But 41's not even, so it doesn't, so 2 wouldn't work. Is 41 a multiple of 7? No, because 7 times 6 is 42. Have you figured it out yet? Yep, you're right. 14/41 is as simple as it can get, okay? Because we can't have a fraction inside a fraction. Okay, it's not, it's really not clear. Like mathematically, it might make sense, but it's not clear and it's hard to read. The purpose of fractions is to keep it in whole numbers for the numerator and the denominator, so it's kind of easier to visualize. Okay, 41 is in fact a prime number. Yeah, 41 is in fact a prime number. So this, despite being very big denominator-wise and having very small pieces, that's as simple as it gets. And that will happen sometimes. You might have something like 14/41. Although I will say, for the most part with fractions, when you're working with fractions, unless it's some sort of like test on bigger numbers and fractions, they're going to be friendly numbers. When you're working in the real world with fractions, they're almost always going to be friendly numbers. Okay? You're going to have, for instance, if you're cooking, right? You're not going to have a recipe that says put 14/41 tablespoons of vanilla into your cookie batter, right? You're not going to see that. You're going to see what? What fractions are we commonly going to see out in cooking or in measuring, right? We're going to see halves. We're going to see fourths. We're going to see thirds. We're going to see eighths. We might even see sixteenths if you're really getting, you know, like a 1/16 of an inch, if you really want to be precise with your measurement. And then you're also going to see tenths or hundredths because those connect to decimals. Okay, so if it's feeling like these fractions are like really big and scary, right? Know that we're looking at some sort of big and uncommon fractions just to give us a little bit of practice. And for the most part, you're going to see friendly fractions out in the real mathematical world. Okay. Thank you for tuning in, everybody. Exit ticket is up on Google Classroom. Math Group B, you are going to meet me on Zoom in just a couple of minutes. And anybody who would like some more help on simplifying fractions, or anybody who would like some help and a little bit of a reteach from yesterday on equivalent fractions using multiplication to make equivalent fractions, feel free to drop in on that Zoom room and get that extra help that you need. All right, take care, everybody. Next live lesson is at 12:30, and it is writing. All right, take care, and good luck on the exit ticket. Just kidding. I forgot. I totally forgot. I knew I was going to do it. I said, do the secret word. There's going to be a secret word on the exit ticket because I wanted to see if all of you are watching till the end of the video. And then I completely forgot to say it. The secret word is penguin. That's the secret word. All right. Now we're ending for real.